Okay, in this video we're going to talk about multiplying radicals and also adding and subtracting radicals. Now, when you're multiplying radicals, one thing you always have to remember is that when you have numbers written in radical form, you can only multiply two radicals if the index is the same. That is, the index for the radical expressions that you have, both of them have to have the same index. So for example, you could multiply, say, the square root of 17 times the square root of 19. You could multiply these together and keep them in radical form because the index for both of these is 2. You could not, however, say multiply the square root of 17 times the cube root of 19. That is not going to work because you have an index of 3 here and an index of 2 there. All right, so assuming that you have two radical expressions and their indexes are the same, there are 3 steps to multiplying radicals. First, you multiply the coefficients. And second, you multiply the radicands. And then finally, you simplify your expression. Now, the coefficients of a radical expression, that's the same as coefficients of any algebraic expression. The coefficients are the numbers that come before the radical symbols. So, for example, the coefficient of this radical expression is 2. The coefficient of this radical expression is 5. So, if I want to multiply these two radical expressions, then I would first multiply the coefficients. 2 times 5, that gives me 10. Then I multiply the radicands. 3 times 2, that gives me 6. Step number 3 is simplify, although in this case I don't have anything to simplify because the square root of 6, that's already in simplest radical form. So 10 times the square root of 6, or 10 radical 6, this would be my final answer. Now example number 2, again I'm going to go through my 3-step process. I notice I have the same indexes here. This is a square root, this is a square root. So I can multiply these two expressions. First I multiply the coefficients. Negative 3 times 1 would give me a negative 3. Then I multiply the radicands. 8 times 2 gives me 16. Now I see my answer here is negative 3 times the square root of 16. Now I can simplify this expression because the square root of 16 I know is equal to 4. So negative 3 times 4 would be negative 12, and that would be my final answer. Now, when you're adding and subtracting radicals, this is actually very similar to combining like terms in algebraic expressions. So here are some expressions in which you'd be asked to combine like terms, and you should be familiar with these. 2x minus x plus 4x. So let's see, 2x minus x is 1x. 1x plus 4x is 5x. So essentially all we're doing here is adding and subtracting x's. Here's another expression, another algebraic expression where we want to combine like terms. So let's see, now here I have some x terms and I have some y terms, and since I only have this one term that has an x in it, it won't combine with anything else. So this just stays the same, negative 2x. The y terms, however, I can combine those. 3y plus y is 4y. 4y minus 6y would give me negative 2y. So negative 2x minus 2y. Now, example number 3, 7x plus 4y, I can't combine those two terms because that's an x term and that's a y term. So this one, you just kind of leave it as it is, 7x plus 4y. You can't simplify that any further. You can't combine those terms because they're not like terms. Well, it's the same way when adding and subtracting radical expressions. Here I have two radical expressions, and I can see that the radical part of the expressions are the same. That is, they're both radical 3. Well, this would be similar to, say, combining 3x plus 4x. 3x plus 4x is 7x. 3 radical 3 plus 4 radical 3 equals 7 radical 3. So I combine these like terms just like I combine like terms with x's and y's. Now here's one where at first glance at least it looks like, well, I can't combine these. This is kind of like, you know, x terms and y terms. This is square root of 12, this is square root of 75, so I can't combine those terms. However, before you decide that you can't combine two radical expressions, you want to first be sure you simplify the radical expression to its simplest form. So I know how to simplify radical 12. I'm going to need some factor trees. So let's see, 12, that's 2 times 6. 6 is 2 times 3. So this is 2 times 2 times 3. So this is 4 times, let's see, 2 squared times 3. And now square root of 75. All right, let's see, 75. 75 will factor into 3 times 25. 3 is prime, so I can't break that down anymore. 25 is 5 times 5. So 3 times 5 times 5 is my prime factorization here. So let's see, square root of 75 is 3 times 5 squared. So let's see, now I can pull this out and I can pull this out. I've got perfect square term here and a perfect square term here. So let's see, that's going to give me 4 times, I pull out that, so that's a 2 times the square root of 3, minus, I pull that 5 square out, that becomes a 5. 5 times the square root of 3. And now I can see 4 times 2, I can multiply those together. That gives me 8 times the square root of 3 minus 5 times the square root of 3. And it turns out that these do, in fact, once I write them in simplest form, I can see they are both radical 3 expressions. So 8 radical 3 minus 5 radical 3 would be the same as 8x minus 5x, which is 3 radical 3.